Okay, good morning. Today I'm going to discuss about the resistance relation with length. Resistance relation with length. We know the resistance formula. Resistance is equal to rho L by A, where rho is specific resistivity. This resistivity depends on the material. Copper, for copper, aluminum or specific resistivity is different. So specific resistivity depends on material. Rho depends on material. If material is constant, then resistance is proportional to L by A. L by A. So, suppose we increase the resistance 2 times, suppose we increase the length 2 times. First, length is increased to 2 times. Then what happens? Increase 2 times. Length is increased to 2. So R will be proportional to L. Area is constant. In this case, length is only increased, area constant. Area constant. Now, in this case, R1 by R2 is equal to 2L by proportional to L by 2L. So R1 by R2 is L by 2L. L by 2L. So R2 becomes 2 times R1. So you can understand, if the length of is increased, resistance becomes 2 times R1 resistance. Like that, if area is increased, area becomes 2 times and length becomes 2 times. Then what happens is R1 by R2 is equal to R is proportional to L. So L means it is L1, that is L by A divided by L by, now L becomes 2L, 2L by 2A. That means L by A by L by A. So second one. So R1 remains R2. See, R1 equal to R2. Now you can see resistance remains constant if the length and area is increased 2 times. Now the third case, let us see, if the area is made half, what will happen? And length is constant. Length is constant. Then what happens is R is proportional to 1 by A only. R is proportional to 1 by A. That means R1 by R2 becomes 1 by A divided by 1 by area becomes half, A by 2. So what will happen is, this is 1 by A divided by 1 by A by 2. That is A by 2 comes top by divided by L divided by 1. Now A by 2 divided by 1. Now 1 by A into A by 2. And that becomes, area becomes half. Area becomes half. That means R1 by R2 is half. That means R2 becomes 2 times R1. If the area of the area is solved, there is inversely proportional. Now we see the area is doubled. Area becomes 2 times. Then what happens is R1 is equal to proportional to 1 by A. Proportional to 1 by A. or you can write easily R1 A1 equal to R2 A2. Okay, easy to calculate. So area becomes 2 times. So R1 A1 becomes R2 into 2A1. Cancel out. You will get 2 times R2 is R1. So R2 becomes R1 by 2. So this half become half. Resistance is, if the area becomes 2 times, resistance will be, because it is inversely proportional, it is becoming half. Okay. So you will see a question: if length of wire extended the line extended to 2 times and diameter becomes half, then find variation of resistance. See, length of the wire extender to 2 times and the diameter made half. Okay, find the variation resistance. So R1 by R2, we know R is proportional to L by A. This is my formula. So you can write R1 proportional to L1 by A1, and R2 proportional to L2 becoming 2L1 by area is becoming, what is area? Only we know the diameter. So for a wire when extended 2 times length L, 2L, and area is becoming half. Okay, so not area is becoming half, diameter is becoming half. That means this length made 2 times, and now if it is D, it will become D by 2. It will become D by 2 now. So area is given by pi r square, and r is the radius, which is equal to D by 2, diameter by half. D by 2, r is equal to D by 2. So what we can tell is area is equal to pi D by 2 square, D squared by 4. Okay, this is the equation, pi D squared by 4. So area is proportional to square of the diameter. Square of the diameter. So now you can write it is proportional, since it is proportional to square of the diameter, we can write this D squared. Now what is happened? So R1 proportional to 1 by D squared, and R2 proportional to diameter is becoming half. So D is becoming D by 2 squared. D by 2 squared. Okay. L is becoming 2L. 2L by D by 2 squared. Now R1 by R2 is equal to this divided by this, 1 by D square, L by D square, divided by, and I think divided by, for each reference, 2L by D squared by 4. 2L by D squared by 4. Okay. That's equal to L by D squared into divided by 2L by D squared by 4 is 4 into 2L by D squared. 4 into 12 by D squared divided by, okay, 4 into 12 by D. Now that is equal to 1 by D squared into D squared by 4 into 2L. Now you can see, if you write like this, it is more easy to understand. There is a error, and chances of error is also less. D squared, D squared. What is getting? L, no, L is L, not 1. L by D squared. Now L is cancelled out. So 1 by 8. Ratio becomes 1 by 8. That is R1 is equal to R1. 8 R1 is equal to R2. So resistance becomes 8 times R1. 8 times R1. Becomes 8 times R1. Okay. Like this also. A1 is pi by 4 D squared is equal to K. We'll put K. Now A2 is pi by 4 D by 2 squared. That is D squared into 1 by 4. That is K by 4. K into 1 by 4. That is K by 4. That means 4 times A2 is K. 4 times A2 is equal to A1. So with that, R is proportional to, now we see R is proportional to L by A. That is R1 A1 is equal to L1. We can write. Okay. Constant is here. Okay. R1 A1 proportional to L1. We can write. Proportional to L1. Now R2 A2 proportional to L2. Now R1 A1 by R2 A2 is equal to L1 by L2. That is L by 2L. Now R1 into AB now 4A2. A1 is 4A2. So 4A2 is C by R2 into A2 is equal to L by 2L. That is 8 times R1 is R2. 8 times R1 is R2. Okay. The length of a cylinder. Length of a cylinder. This is cylinder. A cylinder. This is the length of a cylinder. L. L is the length of a cylinder. Length of a cylinder is increased by 100%. Increased by 100%. Length of a cylinder is increased by 100%. So what is the change in resistance of wire? So since there's a diameter change, now when the length of a cylinder is increased means we will get like this to 100%. Now it is increased by 100%. Increased by 100%. What happened is there is a change in diameter also. Diameter is also changes. Diameter also changes. But see that even if the length is increased, the volume remains constant. Volume remains constant. So there is area into length is a constant. Area into length is a constant. Now I think this is equal to R is equal to rho L by A proportional to L by A. Proportional to L by A. But here area into length is remaining constant. So what we have to do is R is equal to L squared by area into length. That is volume. L squared by volume. So what is L into L? We are adding L here, area into L. L square area into length is volume. So volume is remain constant. Since volume is constant, R is proportional to L squared. R is proportional to L squared. Volume remains constant. Diameter also changes, but the volume remains constant. That is, area and length is constant. That is why we can write like this. Area and length is constant. So area and length L squared by V. This R is proportional to L squared. R is proportional to L squared. So length is increased 100 times. 100%. L is length is L, then L1 is L. First length L1, let's take L1. L2 is L2. Now what is the increase in length? L2 minus L1 by L1 into 100. It means is equal to L2 minus L1 by L1 into 100 is 100. That means L2 becomes 2L1. Same. That is 100% means it will become 2 times. Okay. So what is, we know R is proportional to L squared. That is, R is proportional to L means it is 2. R is proportional to coming first is R proportional to L squared, L1 squared, 2 R is proportional to 2 times L1 squared. That is R1 by R2 is equal to L1 squared by 4 L1 squared. Cancel out. R2 is equal to becoming 4 times R1. What we get is R1 is proportional to L squared. Now let us take R1 is equal to R1 L1, R2 L2. Now R1 by R2 is equal to L1 squared by L2 squared. Here you can see R1 L2 squared is equal to R2 L1 squared. R2 L2 squared is equal to R1 L2 squared is equal to R2 L1 squared. Okay. Now we know L1 is L1 if L1, L2 becoming 2 times L2, 100% increase. 100% increase. 100% increase means it is between 12. Now R1 into L2 means 2 times L1. 2 times L1. So 2 times L1 squared into R2 into L1 squared. So the question comes R1 into 4 L1 squared equal to R2 L1 squared, that is, it cancel R2 becoming 4 times R1. Without also we know R1 is 2 times increase means, sorry, L1 increase 2 times means 2 times L means L squared, since it is proportional to L squared, it will increase 4 times. Clearly, R2 is for R2. R2 is equal to 4 R1. It's for R1. Now, we want to find out the percentage increase. Percentage increase in resistance. It is R2 minus R1 by R1 into 100. Percentage increase. The original length. Difference to the original length. And R2 is 4 times R1 minus R1 by R1 into 100. 4 times R1 minus R1 into 100. That is equal to 3R1 by R1 into 100. 3R1 into 4R1 minus R1, 3R1 minus 100. It becomes 300%. So 2 times increase means 300% increase in resistance, change in resistance. The volume is constant. Resistance variation which temperature. With temperature, the question is RT is R0 into 1 plus alpha T. Alpha is the temperature coefficient of resistance. Temperature coefficient of resistance. R0 can be a reference temperature. Reference temperature can be R20 or R20. 20 degrees centigrade normal temperature can be normal temperature also. So if we find the difference in another temperature, T1 and T2 are 2 temperatures. Difference is delta T. The difference delta T. Then that is T2 minus T1 is delta T. Then you can see RT2 is equal to R0 into 1 plus alpha into delta T. Temperature. That is, increase in temperature decreases resistance. So, when temperature increased, this resistance decrease. Resistance decrease. Temperature increase, resistance decrease. Graph of resistivity with temperature. This is the temperature. T in Kelvin. Now this is the resistivity. Then the graph will be like this for copper. Then material have different, for copper, different material have different little change in graph will come, but this is the normal shape. And for semiconductor, the graph becomes like this. Semiconductor, temperature, resistivity. Okay.